Welcome to This Explainer. I'm your host, Dr. Chem, and I'm speaking to you right now from inside our brand new, completely state-of-the-art cinematic energy science laboratory. Honestly, it's pretty incredible in here. We've got futuristic displays lighting up with these glowing particle animations, totally interactive renewable energy models humming away. We are literally tracking the pulse of the universe itself. And today, we're going to be looking at something that is completely fundamental, yet endlessly fascinating. We're exploring the concept of energy, but not as some kind of static resource. No, we're looking at it as an immortal, shape-shifting force that drives absolutely everything we do. Okay, let's dive into this. Here is the micro to macro journey we'll be taking today. First, the immortal law of energy. Second, energy's many disguises. Third, everyday energy shape-shifting. Fourth, powering the big machines. And finally, efficiency versus conservation. So starting off with Section 1, the immortal law of energy. Imagine dimming the lights in the lab for a second and just watching these glowing particles. Right at the very center of our entire understanding of physics is the law of conservation of energy. It states that energy cannot be created and it cannot be destroyed. It can only be transformed or transferred. Now, what's really interesting about this rule is that it forces us to completely rethink how we view power. We constantly say things like we consume energy or we burn it, kind of making it sound like it's a finite fuel that just vanishes into nothingness. But it doesn't. Energy is actually an immortal shapeshifter. It literally never dies. It just changes its costume and enters a whole new scene. To really grasp this, we need to draw a sharp, contrasting line between transfer and transformation. Think about kids on a playground. Energy transfer is simply moving energy from one location to another, like your mechanical energy transferring to a friend when you push them on a swing. Energy transformation, on the other hand, is the actual shape-shifting. It's changing from one type of energy into a completely different type entirely. Understanding this distinction is absolutely crucial. It gives us a rock-solid foundational anchor for everything else we're going to explore today. Moving right along to Section 2, energy's many disguises. Let's pull up our interactive model here to see energy's extensive wardrobe. We'll rapidly define these key forms. First, we have kinetic energy, which is just the active energy of motion. Then there's potential energy, which is stored power based on position. Think of a massive boulder sitting right at the edge of a cliff. Terrifying for sure, but absolutely full of potential. We also have chemical energy, safely locked away inside the bonds of substances like batteries or coal. Thermal energy, which we feel as heat, is driven by the frantic, chaotic motion of molecules. Electromagnetic energy travels in waves, giving us things like visible light and UV rays. And mechanical energy is the energy of motion used to actually perform work. Notice the contrast we have here. We have the aggressive, active motion of kinetic and thermal energy balanced perfectly against the quiet, stored power of chemical and potential energy. So let's put this into practice with a classic physics setup. Where does the energy actually go when a falling object, say a cart rolling down a ramp, hits the ground and suddenly stops? Well, according to the law of conservation we just talked about, that energy didn't just disappear. There's no way. What we're actually seeing is gravitational potential energy becoming kinetic energy as the cart speeds up. But when it stops, that kinetic energy transforms into thermal energy through friction, along with a little bit of sound energy. It essentially bleeds out into the environment as heat. The total sum of energy at the top of the ramp exactly equals the total scattered energy at the bottom. Which brings us to Section 3, everyday energy shapeshifting. It's time to bring these physics right out of the lab and into your living room. And this brilliantly illustrates how deeply woven these transformations are into our daily lives. When you're freezing cold and you rub your hands together, you're transforming kinetic energy directly into thermal energy. Flip on a torchlight, and chemical energy from the battery becomes electrical and then radiant light in the glowing LED bulb. What about that spectacular natural waterfall you might see on a hike? That's simply potential energy converting into kinetic energy as the water plummets. An electric bell morphs electrical energy into sound, and the very foundation of our entire food chain, photosynthesis, is really just plants acting as organic solar panels, converting solar energy into stored chemical energy. Let's trace the actual flow of energy here. Think about the television sitting in your home right now. It consumes electrical energy, transforming it into light and sound so you can watch your favorite shows. But if you walk up and touch the back of a TV that's been running for a few hours, it's warm, right? It generates heat. This perfectly captures exactly how our shapeshifter works. The initial electrical energy splits into multiple paths, light, sound, and thermal energy, without a single joule ever being destroyed. All right, Section 4, powering the big machines. Now we're going to scale things up to massive global infrastructure. Picture those huge rotating generators and brilliant electrical sparks. A coal-fired power plant looks like an incredibly intimidating maze of machinery, but it's actually just a simple 4-step sequence of change energy transformations. Step 1. Combustion converts the chemical energy stored in the coal into thermal energy. Step 2. That intense heat transfers to water, creating the thermal energy of highly pressurized steam. Step 3. That expanding steam pushes the massive blades of a turbine, turning thermal energy into mechanical energy. And finally, Step 4. The spinning turbine drives a generator, converting that mechanical energy into the electrical energy that powers our cities. We see a very similar chain reaction in a conventional automobile engine, and you can visualize this almost on a molecular level. Cars are fundamentally heat engines. The chemical energy in fuel ignites, converting to the kinetic energy of expanding gases. Then, in a split second, that expanding gas pushes a piston, converting to linear mechanical motion. The piston turns the crankshaft, converting linear motion into rotary motion. Finally, the tires grip the road, converting that rotary motion back into the linear motion of the car speeding down the highway. But there's a catch. Because of the laws of thermodynamics, a substantial amount of the original chemical energy is lost to the surroundings as heat through the radiator and the exhaust. So, a absolutely crucial point here is understanding how we extract electricity from mechanical motion. You can actually visualize this at home by building a simple dynamo, kind of simulating a hand generator. If you take a powerful magnet and pass it back and forth through a copper coil, it induces an alternating current. A nearby compass would literally twitch from the electromagnetic field. This incredibly simple laboratory demonstration relies on the exact same physics used in colossal wind turbines and massive hydroelectric dams. It's just mechanical energy spinning magnets inside wire coils to generate our power grid. The whole shebang is basically just magnets and wires. And that leads us perfectly into Section 5, efficiency versus conservation. Let's shift our focus to how these physics concepts directly affect our daily choices and the global climate. There is a major misconception we need to clear up right now, and that's the difference between conservation and efficiency. Energy conservation is about using less energy entirely. It's making the conscious choice to turn off your television when you leave the room. Energy efficiency, however, is a technological solution. It means substituting technically advanced equipment so you waste less energy without losing the service you want. So, buying a better television that produces less waste heat but still gives you the same bright picture, that is efficiency. Understanding this translates directly into real-world purchasing decisions. Notice the vast difference in device consumption here. An iPad uses a tiny 1 kilowatt-hour over a set period, but an older plasma TV, that consumes a massive 44 kilowatt-hours, whereas a high-efficiency LED screen of the same size uses only 15. That old plasma is drawing vastly more electrical energy and bleeding a ton of it into your room as wasted heat. So let's summarize the efficiency reality. I want you to visualize this like an animated diagram showing energy flowing and branching off. Because our shape-shifting energy is immortal, yes, but it's also very messy. Energy conversions are literally never 100% efficient. Unused energy is almost always released into the environment as waste heat. High-efficiency appliances are meticulously designed by engineers to minimize this exact heat loss. And why does this matter to us? Because maximizing our power-generating efficiency and minimizing loss at home directly lowers the amount of fossil fuels we have to burn, which directly lowers greenhouse gas emissions in our atmosphere. This fundamental physics reality is exactly what is driving humanity's urgent need for better, cleaner, and way more sustainable technology. Which brings us to a final thought as we picture a clean energy future. Imagine wind turbines catching the breeze, vast fields of solar panels soaking up rays, hydroelectric dams holding back rushing rivers. As you audit your own energy footprint, I want to leave you with a provocative question. Since energy is never created, only transformed, try tracing the chain backward. Your electric car runs on a battery, which is charged by the grid, powered by a wind turbine, turned by weather patterns, driven by the uneven heating of the Earth, which is caused by the sun. So as humanity transitions toward a cleaner future, take a moment to look around and ask yourself, where does the ultimate source of every single action in your daily life truly come from? Thank you so much for joining me in the lab today for this explainer. Until next time, stay curious, focused learners.